Hey everybody, let's look at this one from 1976, all the way back then. A classic inelastic collision and energy problem here. So it says a bullet of mass m and velocity v0 is fired toward a block of mass 4m. The block is initially at rest on a frictionless horizontal surface, so no outside forces. The bullet penetrates the block and emerges, so it doesn't get stuck, as it so often does, with a velocity of v0 over 3. So determine the final speed of the block. So this is still a collision, and it still means that it is a conservation of momentum problem. So let's start it off like we should all of them. The momentum of the system beforehand is equal to the momentum of the system afterwards. What do we have beforehand? I'm going to call this the object 1 and object 2. Normally I'd use letters to describe them, but it's bullet and block, so that'd be the same. So let's say this. Momentum of object 1 beforehand has got to be equal to the momentum of object 1 afterwards plus the momentum of object 2 afterwards. So they're not combining in this case. Next up here, let's look at filling in for each of these with the equation. So this will be the mass of object 1 times the velocity of object 1 beforehand is equal to the mass of object 1 times the velocity of object 1 afterwards plus the mass of object 2 times the velocity of 2 afterwards. So I'm just filling in each of the equations for momentum like that. Now let's start to fill in some more specific numbers we have for these. So the mass of object 1 is just m, and then its original velocity is v0. And then afterwards, again, object 1 is just mass m. They told us the velocity afterwards is v0 over 3. And then the mass of object 2 is 4m, and it will just call its velocity of object 2 afterwards, or the velocity of the block. And so now we got to find what that velocity is right there. Okay, so next up, let's keep going here. I'm going to, well, one thing that happens here is, look, masses cancel out of each part there. And so now I'm going to subtract this term to the other side. So I get v0 minus v0 over 3 is equal to 4v2 prime. And then next up here, we are going to sort of solve this. So I think of this, if this is 1/3 v0, let's call this 3/3 v0. Same thing as 1. So 3/3 minus 1/3 is 2/3 v0 is equal to 4v2 prime. And now all we got to do is divide a 4 down onto each side of the equation. And so we'll get v2 prime is equal to 2/12 v0, or let's simplify that, 1/6 v0. So the block will have 1/6 of the original momentum or velocity of the bullet there. Okay, now after that, it says determine the loss in kinetic energy of the bullet. Okay, so let's just treat it like this. The change in kinetic energy is going to be the kinetic energy final minus the kinetic energy initial. Let's find the kinetic energy initial for the bullet. That is 1/2 times its mass times the original velocity squared. It's just straight up that. And so now let's find the bullet's final kinetic energy. It's going to be 1/2 times its mass. And remember, if we look back here, they say that its final speed is v0 over 3. So we'll plug that in here and get v0 over 3 squared. Let's clean this up a little bit here. And so we'll get 1/2 times mass. v0 over 3 squared is v0 over 9. And then we'll just multiply the 1/2 by the 1/9, and we will get 1/18 m v0 squared. All right, the last part here is we've got to actually do the subtraction, right? Because the change in kinetic energy is the final minus the initial. So this minus that. And so we've got 1/18 m v0 squared minus 1/2 m v0 squared. Let's just think of this 1/2 is 9/18. So 1/18 minus 9/18 is negative 8/18 m v0 squared, or let's simplify that down, negative 4/9 m v0 squared. So that's how much energy was lost by the bullet. Let's do the exact same situation, but for the block. So determine the gain in kinetic energy of the block. So we got to find the change in kinetic energy. Again, it's final minus initial. But hey, this is nice because the initial is just 0. and because it wasn't moving at all. So we just need to find the final kinetic energy there. So the final kinetic energy will be 1/2 times the mass of the block, which remember was 4m, times the final velocity of the block. And if you remember that, it was 1/6 v0. So 1/6 v0 squared. Don't forget to square it. I don't think I just said that before. So if we then work this out, let's see here, 1/2 times the 4 will be 2, and this will be 1/36 over here. And so 2 over 1/36 is 1/18 m v0 squared.